Hello students, today we are going to talk about PN junction diode. We will also talk what is depletion layer for a PN junction diode, and then we will discuss the forward bias, what is forward bias, reverse bias, and in what manner it affects the depletion layer of the PN junction diode, and also what is the nature of current voltage variations in these two cases. We shall discuss all these one by one. So now let us talk about PN junction diode. What is PN junction diode? When p-type semiconductor is allowed to fuse into n-type semiconductor, practically it is done when heated or molten state of p-type semiconductor is brought in contact with the n-type semiconductor, that then due to a slow process, these two fuse into each other, and thereby a layer of positively charged and layer of negatively charged ions are formed at the junction area of these two semiconductors, p-type and n-type semiconductors. How this layer is formed we shall discuss. So let us look at the figure. Here we are having a p-type semiconductor which is separated by a large vertical dotted line, and the left hand side is p-type semiconductor and the right hand side is n-type semiconductor. How p-type semiconductor form? You all know that when we have trivalent impurity doped into a intrinsic semiconductor, there is always a vacancy of one electron created. This vacancy of electron is termed as holes and behave like a positively charged particle, which is though virtual, but its behavior is exactly in the same manner as if it was a positively charged particle. And in the n-type semiconductor, what we have done, we have doped the pentavalent impurity in the intrinsic semiconductor so that one electron is left unpaired, and that this electron is called the majority charge carrier of n-type semiconductor, and holes are called the majority charge carrier of p-type semiconductor. Now, apart from the majority charge carrier, there are a few minority charge carrier as well created at room temperature, because when a material is kept at room temperature, what happens? Some of the bonds, electron and hole pair, are released due to breaking of some bonds, and these bonds creates equal number of electron and holes. So we have some electron as a minority charge carrier in p-type semiconductor, and we have some hole in n-type semiconductor as a minority charge carrier. Now when we allow these two types to come together, when they are brought close, you see on the n-type semiconductor we have excess of electron, lone pair electrons present, and on the p-type semiconductor, in the p-type semiconductor we have excess of hole charge carriers. So due to difference in the density, electrons diffuses from n-type into the p-type, and as this happens at the junction, when it moves into the p-type semiconductor, immediately it is leaving behind a atom which is positively charged, because one electron left the atom, and when these electron reaches the p-type semiconductor, they combine with the holes, and there they form a layer of negatively charged particles. sorry for interruption. And so there is a layer of positively charged particles, positively charged ions on the n side semiconductor close to the junction, and there is also a layer of negatively charged ions on the p type semiconductor close to the junction. This creates a electric field, and it opposes the further flow of electron due to diffusion, because you see this electric field due to the layers of positive and negative charges is along my left from my right. So that means the holes which tends to jump into n-type semiconductor are opposed, and also the electrons which tends to jump into p-type semiconductor are opposed due to this depletion layer. So finally a stage may come when the transfer of electron from n-type to p-type, or by the same matter the transfer of hole from p-type to n-type due to diffusion stops, and this final voltage at the junction created due to the layer of charged ions is known as depletion or barrier potential for that given p-n junction diode. Now when we connect p side of a cell of a battery to positive side of a cell or a battery to the p side of the semiconductor, means p type semiconductor, and we connect the negative terminal to the n type semiconductor, then this type of biasing applied across the p-n junction diode is known as forward bias. Now if we have done like this, what happens is an external electric field is now opposing the depletion layer or barrier potential, and therefore the barrier potential is reduced. The width of the barrier potential is reduced under the influence of external field, but it never becomes zero. The reduced value for a typical case of depletion layer is nearly 0.6 volt. So that means so long the forward bias is less than 0.6 volt, no current will flow through the junction diode. Means if we have a ammeter connected over here, of course you can attach a voltmeter connected over here. If we have a ammeter connected over here and you have a voltmeter connected over here, you will see that no current will flow so long the voltage applied, forward voltage applied, is less than 0.6 volt. For a typical case, I am talking about any typical case where this happens, that depletion layer voltage becomes 0.6 volt. And then once the forward bias voltage is raised above 0.6 volt, the current starts flowing, forward current starts flowing through the p-n junction diode, and that current is in few milliampere. If we plot a graph for forward bias diode current, we are plotting diode current on vertical y-axis and the forward bias on the horizontal x-axis. Then you see that here you see the forward current is starting from not from zero. It is starting from some point, and which we have just talked. We have taken is, for a typical case, is 0.6 volt. So once the forward bias value is greater than 0.6 volt, the current starts flowing through the diode, and it increases very rapidly by leaps and bounds as we keep increasing the forward bias voltage. Now if we reverse the polarity, of the battery applied across the PN junction diode, that means if this terminal P type is connected to negative pole of the cell and N type semiconductor is connected to the positive cell or terminal of the cell, then in that case that type of biasing is known as reverse bias. And for that case, in this case now what happens, when we consider the reverse bias case, the external electric field is no longer opposing the depletion layer. Now both are in the same sense, because if we consider this new situation of biasing, means N type is connected to positive terminal and P type is connected to negative terminal, then in that case the direction of external electric field will be along the direction of that of depletion layer electric field due to depletion voltage. So that means these two now are in same sense, therefore the width of the depletion layer, the width of the barrier is increased because it finds favorable field with the external field applied across it, and the width of the depletion layer increases. Now in this case the holes present, the minority charge carrier, that is the holes present in the N type semiconductor, plays an important role, and majority charge carrier are no longer playing any role, because when holes are the minority charge carrier present in N type semiconductor, they are repelled by the external electric field positive terminal, and so these holes starts moving across the junction and then they reach the negative terminal. Once it crosses the junction, it reaches the negative terminal and easily goes to the negative terminal of the cell. That means current starts flowing but in reverse direction, that as compared to in case of forward bias. In case of forward bias, the current direction is from positive terminal, that is P type, towards the N type, but that means it is within the diode, it is from N type to P type. But when we talk about reverse bias case, in this case the current starts flowing from N type and it moves towards the P type. That means within the diode current flows now from P type towards N type. So therefore the current which is positive, taken positive in forward bias case, the current is taken in the third quadrant, it is taken as negative, and the reverse due to the reverse bias applied across the diode. Now since minority charge carrier do not have any opposition from the field because both are in the same sense, and therefore the current starts from the very low bias voltage. Even at very low bias voltage, current starts flowing due to the minority charge carrier. However, the magnitude of current is very low because of the fact that the minority charge carrier are very few in number, because minority charge carrier are created only due to the thermal energy received by the bond making electrons and getting getting the hole and electron pair freed. So this happens only with the few bonds, therefore we have only few number of minority charge carrier, and therefore we have very poor reverse bias current. However, for a particular reverse bias voltage, the current starts increasing very abruptly. That particular voltage of reverse bias is known as breakdown voltage. why this happens, let us understand. As we increase the reverse bias voltage, the thick of the depletion layer keeps increasing, and therefore as the and so gradually we can very much visualize that gradually if we keep increasing the reverse bias voltage value, the width of the depletion layer keeps increasing, and finally it may overlap the whole p-type and whole n-type junction. And for that case, what happens, the whole p-type will become negatively charged and the whole n-type will become positively charged, and that means there will be a short circuit, there will be no opposition to the flow of current. So therefore we start getting very high current at that particular voltage and beyond that voltage. So that therefore we call it breakdown voltage, because at this voltage the current increases abruptly, as if the avalanche takes place when the dams are broken, means the electrons start flowing in abundance, and therefore we call it breakdown voltage or avalanche voltage or Zener, we also call it Zener voltage. We shall talk about the Zener diode in the coming lectures. That's all for today. Thank you and have a nice day.